So I will be doing module 4 chapter 9 question 3 and 5. So for question 3, the prompt says, playing a board game, you are stuck in jail until you roll doubles, which are the same numbers on a pair of dice. You will simulate using random digits to estimate how many turns you expect to remain in jail. Identify the component if you were to run a simulation. So a simulation is it models a real world situation by using random digit outcomes to mimic the uncertainty of response variable of interest. And a component of a simulation uses equally likely random digits to model simple random occurrences whose outcomes may not be equally likely. So because I am running a simulation, my component in this case will be rolling a pair of dice. So I did a simulation of 30 trials, and these are the amount of turns that I came up with. So it shows that I've went up to the 20th turn in order to get a double while rolling the pair of dice. And in sheet 2, I ended up decreasing the number of how many times I had came up with for these. So in my chart, the mean was 7 altogether out of the amount of out of the amount of doubles that landed on specific turns, and my median came out to be 6. So after I did my table for turns and frequencies, I did my standard deviation, and it was 1.38. So after I did that, I decided to create a histogram which displays the amount of times of doubles that I got for each turn that it landed on. And for going back to question 5, it says, for the board game described in exercise 3, how will you combine concepts to model a trial, and what is the response variable? So a response variable are values of the response variable record the results of each trial with respect to what we were interested in. So for combining components to model a trial, I assigned my outcomes to my components of the simulation. I randomly assigned the numbers for each turn using the formula rand between. So I can show you on the side over here. And I use 1 through 6 just because the highest number on a number dice can go up to 6, but if there's 2, so I did 2 dices. So I did that, and then you just press enter. So that's how I came up with my random numbers. So it's like we are pretending that we are rolling the dice until it lands on doubles, and I did this by using the formula for each turn to make it random. So the trial would be completed once there are doubles for each trials of the simulation. So we complete all of these until each has landed on doubles for a turn, and the response variable is what we want to find out the number of times doubles will be rolled. So that is question 3 and